Welcome, everybody. As always, please feel free to ask questions along the way if you're watching live. If you think you might like to come on the show yourself, please do get in contact. My details are on the Channels About page. Next week, we'll be talking with Rachel Mant, aka Dragon Mux. But today's guest is Carrie Sundra from Alpenglow Industries. Hello, Carrie.
Hello.
Oh,
how's it going?
Apologies. Yes. Hi, Nikki. How are you?
Good.
Would you like to just introduce yourself quickly? Who are you? What do you do?
Sure. My name is Carrie Sundra. I have a small business named Alpenglow Industries, and it's named after a light effect that happens in the mountains when at the end of the day you have these really long wavelengths of light, and it lights up mountains with this glowing reddish orange color. So
okay,
anyway,
so this is right on the edge of sunset, is it?
Right? Sunset or sunrise. Yeah, happens both. Depends
Awesome.
upon which way your mountains are facing and stuff.
Yeah. Nice.
But,
I like it. Cool.
So yes, that is what Alpenglow is named after. And my business is also around getting people to see electronics in a different light, and and provide just easy, not very intimidating entry points into soldering and just learning a little bit about circuits.
Brilliant. Okay. Thank you.
Yeah.
So we'll get onto that in a bit more detail later, but I always like to start with people's backgrounds and how they got to where they are today. Would you mind just giving us a quick overview of your childhood and onwards?
Yeah, sure. So I grew up in the U.S. Virgin Islands on the island of St. John, and the U.S. Virgin Islands is a territory of the United States. And so, yeah, there's a lot of... it's not a state. There are no voting rights there, which kind of sucks. But yeah, it was a really fantastic place to grow up, and but it was not very tech savvy or tech heavy educational wise. It's a little bit slower to adopt technology in the Caribbean because the infrastructure is just not there and very different. Yeah. So I didn't have a ton of opportunities to interact with tech or to, build robotics or anything like that. But I did take all of the science classes that I could. And my dad was an engineer who worked on the Apollo programs. And so he had a deep love of science. And so, he got me interested in computers and got me, cool toys when I was a kid, like a Merlin and a Speak and Spell.
Nice.
Yeah.
Cool.
Cutting edge electronics toys for the time.
Yeah. Awesome. So when you grew up a little bit and moved on to high school, and you said you took all the science classes you could, but there's obviously no electronics, no computing as such, I guess. It was sort of...
No. So yeah, it was a shame. We had a really great teacher he was I guess he was the computer lab instructor, which was also like one of the only 2 air-conditioned rooms.
Nice.
So it was always kind of nice to
hang
go
out.
in there. Yeah. But it was funny in 7th grade, we had quote unquote computers in 7th grade. And this is on Commodore 64s too. So computers in 7th grade. And then we also had and that was, I think, for only a couple of months or something. And then in high school for half the year, there was also a computers course. And so his big thing was I'm going to teach y'all to type in 7th grade when your little brains are nice and, nice and impressionable and can learn things, especially manual and dexterity things real fast. Yeah. And then so when you all get to 9th grade and I have you again, programming, and I was like, yes, this will be great. And between 7th and 9th grade, he moved or whatever. And awful old lady who didn't know anything about computers who taught typing again in 9th grade. Nice. So yeah, and I was like, I already know how to type. Click. So yeah, we did not have a lot of computers in school. I did have physics in school, but we didn't really have a lab component with it. So I learned very basic book-based electronics in physics. Yeah.
Okay. Fair enough. Yeah. And then after high school, you moved on to college. I think you said California. Can you talk us a bit about that?
Yeah, I went to California. I went to Harvey Mudd College. It's in Claremont, so near LA. And it's a small but very well regarded science and technology school. And I knew I wanted to do science and tech because I loved it, but I didn't know what I wanted to do specifically because I hadn't been exposed much, right?
That's the thing, yeah.
That's the thing. How do you know when you haven't even taken any classes in engineering if you want to be an engineer? So Mudd it fit really well for me because there was a really big emphasis on having in growing engineers that have a broad background and also understand the impact of their actions on society. Okay. Yeah, so a third of our classes had to be in humanities. A third were in a core science curriculum, so like biology, math, physics, chemistry, computer science, and engineering. And then a third of our classes were in our major. But right. Even as engineers, they were kind of like, yeah, specializing is for grad school, and we don't do grad school, so we don't do specializing.
Okay.
So even in engineering, I had chemical engineering, computer engineering, electrical engineering, mechanical engineering, and a lot of what they called systems engineering, but what most people would call controls.
Okay, interesting.
So very broad background.
Okay.
But it was great because I got to try all these different things. And, there was maybe a little bit of process of elimination in my major.
Yeah. Okay.
I was like, oh, don't want to be a chemist anymore.
Fair enough. Too many things going pop.
Just too much lab time.
Okay. So you mentioned, making well-rounded engineers who are conscious of their decisions, actions in the greater sense of the world, I guess. Can you just talk a little bit more about that and sort of how it affected maybe your mindset going forwards and things?
Yeah.
Big question.
Well, in high school, I loved AP English just as much as I loved AP Physics.
Okay.
And I think my mom was a little scared at one point in time, like before I went to college, that I would follow in her footsteps and be an English major. And she thought that was a terrible idea because, no jobs and and stuff. But that was really never on the table. But it was still an important part of my life and something I wanted to do and not ignore. And I think it's very easy to get into a rabbit hole of topics and being surrounded by people who are like just like you and have your same kind of socioeconomic background and things like that. And definitely through the course of my life, my different hobbies, as well as just being really open-minded and figuring that like I can probably learn from anybody, like learning from this technician who has been doing electronics for 30 years. I'm probably going to learn a lot from him just as much as I am going to learn from this engineer who has also been doing electronics for, however long. So, I think it's important to do things that take you out of just the social circles that your workplace provides.
Your blinkered little world. But absolutely.
Yeah. And I mean, it's not like I don't want to say like, oh, you shouldn't like that world, right? I mean, there's great camaraderie in tech, and it's great to be talking to somebody who shares your like weird little esoteric interests and stuff. Because so many of us come from this perspective of, oh, well, I was the outlier in high school or in my family or whatever, and it's so nice to finally like find my people, but just, don't get blinded by that too, because there are lots of awesome people out there. So
nice. Okay. So during college, you did a number of broad range of topics, and was there anything in particular that stood out as your favorite that hooked you and has stayed with you ever since almost?
Yeah, I really loved classes that got me into the machine shop.
Okay.
Those were my favorites. And the classes that I had that were more manufacturing based were really interesting because they were very, learning how to use machine tools, like it was very hands-on, and all of a sudden it gave me these skills to make things that I could not do before. Like it just opened these doors for me. And then we had this class called manufacturing and metallurgy. And at the end of the class, the big project for it was that you had to make 10 of something.
Okay.
And that taught me more about manufacturing and just the processes and the steps and things you had to think about and do than any book reading could have.
Yeah.
Actually having to do it yourself.
And I guess 10 is a good number because it sort of gets you into the swing of it as well, where it's not just the one-off, but you can learn from the previous, that kind of thing.
Yeah, totally. And full disclosure, I still need to sandblast and assemble that project. I didn't.
No comment.
I need to hit up a friend with a sandblaster or a bead blaster and finally finish the assembly of those things. Like,
that's one of the frustrating things about school, isn't it?
Oh, my 25th college reunion is coming up next year, so actually this should be a good goal for me, is to get them done by that point in time.
That'd be cool. Yeah. I always found that as one of the frustrating things of school, where you have lab time, but it's always a matter of it's your slot, if that makes sense, and you can never quite get to where you want to, or you finish too early and you've got loads of dead time after it. It's sort of one of those frustrating things. Anyway, after college, what did you go on to do then?
So my first job was for a company at the time that was a small weird company doing these weird unmanned aircraft, and it was called AeroVironment, and there were like 45 of us in that division that was working on weird aircraft, and we were sort of like the redheaded stepchildren of the company. The rest of the company was like really enthusiastic about their electric car chargers and electric forklift chargers and stuff. And I mean, they were really like 15 years maybe before their time with that kind of stuff. I think 15 to 20 years, but yeah, it hadn't quite caught on yet. So, they were spending a lot of money with marketing that stuff. And we were sort of left on our own to like get these NASA and DARPA grants and work on weird aircraft.
Okay, cool.
Yeah. So it was a bunch of like really cool, talented, mostly model airplane nerds. And then me, I was like the only one who wasn't a model airplane nerd, but but I was very appreciative. I was like, oh, these are cool, and I want to work on them, but I just didn't have that background of like tinkering on them since I was a kid.
Fair enough. Okay. Nice. So when you say unmanned aerial vehicles or aircraft, I can't remember what you said. What does that mean? Can you expand on that a bit?
There were a wide variety of projects. So one was NASA funded, and it was making a solar powered airplane, which eventually did go on to break the record of highest altitude propeller driven aircraft. So
amazing.
And yeah, they went to 100,000 feet. That one wasn't entirely solar powered at the time. That was like battery powered as well, battery and solar. But yeah, so they were doing really cool stuff, and there was this wealth of knowledge about how to build really strong, really light airframes, and ones that were relatively stable, or at least that they understood the idiosyncrasies of. I mean, there were a lot of spectacular crashes too, but and so it was everything from that, and that thing had like a 120-foot wingspan. I think it was like basically a big flying wing. And down to the project that I started working on pretty soon after I got hired, which was the Micro Air Vehicle Project. And that was a DARPA grant, which in the US, it's the Defense Advanced Research Projects Agency. So they basically throw money at small companies to try weird cutting edge stuff that doesn't exist yet. And,
it's kind of blue sky. If it doesn't work, it's not the end of the world. Just have a go kind of thing.
Yep. And there are phases. So like if your thing actually works, then you might apply for phase 2 and get more money to develop it. And so there are things that have like gone through DARPA and like made it into production. But yeah, so at the time there was the 6-inch fully autonomous micro air vehicle challenge
Wow.
to make a 6-inch flying thing in 1998. So
That
you
sounds
know,
very, I don't know, daunting, I guess, for the age of the time.
yeah, I mean the battery technology was terrible,
Yeah.
sensors were awful, like truly awful. Like the gyros were like really awful. Like you people might have used like a really old mouse that like all of a sudden just starts drifting all over their screen and things
Right.
like that, and you're just like, what is this thing doing? Yeah,
Going
imagine
on.
that gyro in an airplane.
Nice.
So yeah, we were doing
Okay.
all sorts of crazy stuff, like taking pressure sensors and like milling them down to shave off weight,
Wow.
cutting
Okay.
off pins because that's 1/10 of a gram, and
Yeah,
that's
we want that.
important.
Okay. So if you said, less than 6 inches today,
Yeah.
it would be a multi-rotor quadcopter type design, almost certainly.
Yeah.
But you mentioned aeroplane just now.
These were fixed wing, yeah, forward
Okay.
flying things because yeah, it's a good question as to why sort of like the quadcopter design wasn't sort of the first one. And there were some things that some bigger platforms that AeroVironment was experimenting with like vertical takeoff and stuff. That stuff tends to need a lot of power, though.
I think
To
that's a large part
get
in
it
the
off the ground.
processing to keep it stable is
Well, yeah, well, and that just the first launching, the first, amount of power needed to get it off the ground was pretty high. And the, lithium polymer batteries weren't really a thing yet.
Yep.
The small lithium ions still had a metal, like were completely metal encased. They weren't like your 5590, or sorry, not 5590. They weren't your 18650 form factor, but they were kind of like lithium polymers, but just like little metal,
Okay.
bricks
Interesting.
instead of the really lightwait
Okay.
foil.
Yeah, neat.
So
Okay.
so the energy density wasn't really there, and I mean, I don't think the materials technology to build them was certainly there at the time, but I think it was mostly kind of like an energy density thing, and also being able to have a processor with enough power to drive these four, and again, being able to sense any kind of inertial like position, orientation, direction. That was really challenging. I mean,
I was going to say I don't have a good reference for when MEMS came about, but I would imagine this was not MEMS.
This was pre-MEMS. Yeah, this was all pre-MEMS. Like, I remember how excited we all were when the first MEMS gyro came out. It was this Analog Devices one, and it was like, I don't know, it was like this big or so.
Yeah.
So it was, easily like 6 times the size of current ones. I mean, it was probably like 20 times the size of current ones, but it was still like maybe like a centimeter square kind of a thing.
Yeah.
It was a single axis.
Right. Yep.
But it was amazing because it was the first one that had any kind of decent temperature performance and wasn't really impacted too much by like dropping it. And yeah.
Oh, yeah. Imagine that.
Yeah.
The early ones, I would guess they are pretty fragile in terms of dropping.
Yeah, because they were all like the vibrating bar style, and yeah, they were really fragile. And even those, they were made by Murata, and they had a your basic kind of like plastic that's used for ICs, right? The black kind of brittle plastic. I'm not sure exactly what it's called, but they had that kind of a body, and then like a metal can over the top.
Yep. Okay.
And we were actually taking off the metal can and putting like a thin fiberglass sheet over top of them because the metal can was too heavy. And yeah, I broke a fair number of gyros, but eventually got pretty good with CA gluing the little fiberglass thing on top.
Okay. Neat. So over your time there, I think you started branching out and learning more and more and more, particularly electronics and things. Can you talk about
that? So I hated electronics in school. I hated it. It was terrible. It was awful. It was boring. It was like esoteric. We didn't have a lab class with our electronics. We kind of had this one lab class which sort of tried to smush one lab from each engineering discipline all in this one lab class.
Mm-hmm.
And it didn't work very well.
Okay.
But it was funny because I maybe should have paid attention to myself a little more. The lab that I liked the most, that I just sort of like got the hang of the easiest, was the digital logic one. So that's probably the first time I used a breadboard, a solderless breadboard. And I was like, oh, holy shit, this thing actually works. Like, look, ones and zeros. It's doing what it should.
Awesome.
Yeah, that was real exciting. And that joy of seeing something, work that you had just like read about and done equations about and stuff like that. That was
now
great.
It's actually happening. Yeah.
Now it's actually happening. Yeah.
Very cool.
So I hated electronics in school. I was like, I need to do hands-on stuff. I'm going to build stuff and use machine tools. And then at my first job, like their funding got totally scrambled, and I ended up on this micro air vehicle project. And they were like, well, we kind of need, like an intro engineer and somebody who can be an electronics technician. And they knew that I had, for a job in high school, I had learned how to solder jewelry with a propane torch. And we're like, oh, we could teach her how to solder electronics.
It's not that different.
It's fine. It'll be fine. And so I started soldering electronics. And the thing that I appreciate now that I didn't really appreciate as much then is that everybody was basically like, oh man, this stuff is small. We'll give it to the 20-year-old eyes to solder. And now I'm like, oh yeah.
It makes sense.
That was a good call. But yeah, I pretty much solder. I learned how to solder under a microscope there. And I'm very comfortable soldering under a microscope. I prefer to pretty much solder everything under a microscope. So
fair enough. Okay.
But yeah, once I actually had this practical application and there was this cool project that we were trying to do, like,
there's a good reason for learning it and doing it. And
all of a sudden it was much more interesting. And I was like, oh, this stuff is super cool.
It's amazing how frustrating and difficult the sort of the teaching side of it can make these topics, isn't it? They're very dry and disengaging, and we'll come on to that in a minute. We were talking before we came out live about how you're the only woman in your field, and you're sort of working not in isolation, but by yourself almost for quite a number of years. Can you just expand on that for a bit?
Yeah, I mean, at AeroVironment, when I got there in our division, there was one other woman engineer, and she was basically just on a completely different projects than I was. So our paths just did not cross.
She existed.
What's that?
She existed. Not much more than that.
She existed. She was super cool, very, very capable. Yeah. She was also like a bit introverted. She was pretty quiet and not very outgoing. So we just didn't, we just didn't interact very much. And basically, for my entire time working in UAVs, I never worked with another technical woman on the team.
Okay.
Yeah.
And how did you find that? How did it affect you, and what did it make you think about the world, the job you're in, etc.?
Yeah, it's interesting. Like, you learn some defense mechanisms, I think, even before you understand that that's what's going on. And it's taken me a lot of being out of that world and looking back on it to really kind of process that and understand what happened during that time. And during that time, I was pretty much in survival mode. I needed to be taken seriously. I needed to show that I was tough, that I wasn't like those girly girls, right? That I was smart.
Okay.
And so, and naturally I do have a reasonably aggressive personality. I don't back down easily on things, especially when I have an opinion about them. So, that definitely helped out. But, I think that I definitely made that mistake of being so in it that I was a little bit dismissive of other women at that time. And like,
Okay.
that is definitely a thing that I regret and that I take pains to not do now, because there are all sorts of women doing all sorts of like amazing things in electronics, things that I can't do. And, you know, it doesn't matter if you like makeup or like to dress up or are doing, you know, wearables or whatever, like that doesn't make it any lesser.
Yeah.
And people should just have the freedom to be who they are and still be respected with what they do. So
absolutely.
yeah.
Thank you.
But yeah, it was hard. And if I had had more women around me, then I might not have kind of gotten into that mode so deeply and so hard for my intro years.
Okay. Was it at all daunting going into this? I don't know if college was similar in terms of the, you know,
college was definitely similar. Because I went to a science and tech school. There was the ratio at about that time was like there were about 3.5 to 4 men to every 1 woman at school.
Okay. It's not quite as bad as expecting, actually, which is interesting. But
yeah. But it was still very much we were still very much minority, and there were still, a lot of the like, oh, haha, kind of like, I'm going to make a sexist joke. Isn't it funny? Kind of things. And it's like, actually, it's not, because it actually happens and it's not actually a joke. So, yeah.
Okay. Yeah. Thank you for talking about that. It's,
a
big thing that's, I think, worth spending some time on.
And it's also like, if you don't see other people like you who are doing stuff, then yeah, it feels even more isolating and alone, and that it's just not for you, right? That you're like not welcome, and
that's a big part of it, isn't it? It's the I can't see anyone who I identify with in this world, therefore why would I be that kind of thing, I guess.
Yeah, and because of that, maybe I don't belong here.
Yeah. Okay.
Yeah.
So during your time playing with tiny flying things, you spent, I think, was it 12 years there? And towards the end of it,
different companies, but in the field.
Oh, okay. Apologies. Yeah. Okay. Towards the end of it, then you got a bit overwhelmed. Do you want to talk about that?
Yeah, I got burned out. I totally burned out. And it was like a combination of all that stuff, and as well as feeling that I had really no control over the direction of the company that I was working in, that I had like really no input in that, and that I wasn't like part of a team that was like deciding that future or helping enable that future. So so I was just like, well, why the hell am I working my ass off for somebody else? And
absolutely.
So I decided to start dyeing yarn, and
Amazing.
did a hand-dyed yarn business for a while.
Awesome. Okay.
I was really into knitting and crocheting and spinning my own yarn, and still am.
Is this a thing that had been around for a number of years already, or is this something that you got into as a result of burnout?
I got into it more for sure, but I had already been like doing like knitting and crocheting and kind of like some textile work with my hands for a number of years. I got into it because my first set of friends, when they had their first kid, like, that was all exciting. And my mom used to crochet baby blankets for people who had their first kid and stuff. And so I really wanted to do something that was handmade, that I didn't just want to buy them a gift. I was like, I feel like that's like the lazy way out. Now I'm totally taking the lazy way out, by the way. But at the time, I was like, I want to do something with meaning. And so, so I was like, hey, Mom, can you teach me how to crochet again? I mean, I know you did when I was like maybe 7 or something, and I don't remember. And she's like, oh, man, okay, I have to remember too. Hang on. So she taught me how to crochet, and then I stuck with crochet for a long time, and then she kind of got into knitting as well. And her mom had taught her how to knit, but she hadn't done very much knitting. And so then I started to see what she was knitting, and then I got into knitting. And then it was like just a rabbit hole of fiber and yarn. And the person I was dating at the time, his family had a ranch up in Mendocino, and they raised sheep. And so the sheep were like reasonably good for fiber, and the wool price was shitty. And so I started buying fleece, and I learned a lot about like manufacturing yarn and, you know,
amazing.
Fleece are good, and fiber and wool. And,
Nice.
It's very interesting because it's basically, you know, knitting your own garments. You are engineering something, but just with yarn. There's an amazing amount of skill and, you know, calculation that goes into making a garment that actually fits your body. And knitwear designers are very impressive in their skills. For sure. And, you know, you have to factor in the material properties of the fiber that you're using too, because if you make the sweater out of cotton, it's going to behave completely differently than if you make the sweater out of wool.
Okay.
So, yeah. So it's very much a materials engineering.
Yeah. It's one of those, you're still doing what you wanted to be doing, but in a very, very different way, I guess.
Yeah.
Nice. Okay. I guess there's a lot involved in the dyeing and things as well, in terms of what you can use. Is it color safe? Is it the right word? Is it fast?
Yeah. And the thing that spoke to me the most than what I was doing is I was using natural dyes, which is it's a more complicated, more labor intensive process because you sort of have to dye your wool twice. Colors, like things that are colorants, don't really bond well with wool just on their own, or cellulose even. So you have to use this intermediary binder called a mordant. And so, and mordants are typically metal salts. And so you first like bathe your yarn in this hot bath of a metal salt, and that binds very well to your fibers. And then you repeat the process with the color that you create from like flowers or bark or bugs sometimes. And and then that actually dyes, and dependent upon what mordant you use, that can affect your final color and, you know, the light fast and color fast properties of it as well. So that was super interesting to me because that was just kind of like being a crazy chemist. Although don't ask me about any of the chemistry. It's organic,
it's just magic,
crazy stuff. And it's just it's a lot of like experimenting and reading people who have studied this much more than I did.
Fair enough. Good. I think you then sort of progressed onto building tools for yarn people. I don't know what to call people who use yarn, knitters, crocheters, etc.
Yeah, well, it's my tools are more for other yarn dyers, so they're for other businesses, other people who are in this artisan manufacturing and who are selling their yarn to consumers, to knitters and crocheters. I don't have anything yet that's like really relevant if you're a knitter, that you would find very useful at that level. But I kind of got to this point where the dyeing, where I would have to make some decisions about scaling it up in order to really be to really like make a go at it. And I was just like, oh, I don't think I love this enough to do it. And at that point in time, like a friend of mine swung by and convinced me to join his crazy Silicon Valley startup. And I did that for a year and was like, this is why I left.
Oh no.
and they made me manage software people, and that was terrible. So I had this like pent up angst of like, oh my God, I have to build something just to prove to myself that I still got it. Like I can still do this. Right? And I started building yarn tools that I wished that I'd had as a yarn dyer. And I like that a lot more. And it's a much more fun for me business to be in. And it's pretty unique because not a lot of people build tools for other people who are in this small dyeing world.
Okay. Do people tend to sort of build things to make the work easier for themselves, and there's no real sort of industry around the tools, or what's going on there?
Yeah, and there have been like a couple of, there have been a couple of like small businesses where that are like typically husband and wife teams. So it's typically like the wife got into yarn dyeing and we're like, hey, husband, you're handy and you know how to like build some machines, and I need a machine that does this.
Okay.
And then you wind up with a machine that does this. And that's very useful. And like, certainly I'm happy that other people are building actual winders because I don't really want to build bigger machines at this point. But at the same point in time, there was this difference between the people that were using the machines and the people that were building the machines.
Mm-hmm.
And so because I had been actually doing the dyeing and I had this really deep understanding of the problems in the workflow as well, it set me up to be able to do some things that other people like hadn't considered. Plus my background in electronics and knowing how to design circuit boards and get custom electronics made and buy that stuff, it all kind of dovetailed really nicely.
I hadn't expected you to bring electronics into the tools. I would just presuming they were fairly mechanical, but that's unexpected.
Yeah.
Cool. Okay.
So the first one that I built, I played it safe and I did pretty much an entirely electronic tool because that's what I knew how to make, right?
Okay.
I knew how to source electronics and get electronics manufactured. And I was like, oh, mechanical parts are not necessarily my forte. I know, right? Total reversal from like when I graduated from school. And so yeah, I'm like, I'm going to play it safe because I need something that I have deep experience with to be comfortable actually going through the process of selling these things to other people and not having it terribly blow up in my face. So yeah, it was my first product was literally a black box with a big red button because you gotta have a big red button. And it is a controller for these other yarn winders that other people were already making.
Okay.
Because they were super simple. It was a motor basically hooked up to like a dimmer switch to control speed, and you plugged it in and, it went. And they had rotation counters on them, but they were just hooked up to like an LCD or even like the mechanical clicky type, right?
Awesome. Yeah.
Yeah. And so like you could tell what rotation count you were at, but there was no automation to it. So it was this awful process. Yeah. Like, so, okay, you're a yarn dyer.
Yeah.
You sell yarn. You need all of your skeins to be the same length because when people are buying a skein of yarn, it has to be consistent. If it takes like 4 balls of yarn to make a sweater or whatever, right, they have to all be the same length. And so it was this awful process of being like having to babysit a machine. Like a human had to babysit a machine. So you'd be standing there watching a rotation counter click up. And the whole thing, depending upon the length of the skeins you were winding, it was like maybe anywhere from 1 minute to sort of like 3 minutes. And it's like, it is just the amount of time where you can't leave it to go do something else.
Yeah.
Barely, like you couldn't even leave it to go pee, practically. It's like, and, but yet it's too long to hold your attention. Like you'll get really bored just looking at that counter for 3 minutes. So it was this awful thing where like you'd be watching it, you zone out, then you'd be like, oh shit, and zone back in.
Missed it. Yeah.
You missed it. And now you have to stop it. And you're like, okay, I'm 19 turns past. And so then you have to be like counting to yourself, okay, like an unwinding. And then you
got
have
a mess
of spaghetti yarn. And so much time wasted. So yeah, what if somebody made something? What's really good at counting? Microprocessors. They're really good at counting. Yeah, and that was actually my intro into embedded programming, was doing the software for that. And yeah, and I got started with Arduinos, and then I was like, oh, this is why all those like couple of C programming classes that I had, 15 years ago at the time or whatever, like, this is what I can use them for.
That's where they were going.
Oh, it's so much more interesting because now it's my problem that I'm trying to solve. Yeah. And of course I'm interested in like what the heck a uint8 is and why I care and like, yeah, all that stuff.
Amazing.
So, yeah.
Brilliant. That's so cool. Yeah, awesome.
Okay. So, yeah, and then I started doing contract work. So I was sort of half yarn tools, half contract work. And then I had a crazy client who went off the rails during COVID, and I was like, I want to do more stuff that I like. So now I'm making, instead of still doing yarn tools, but now instead of doing consulting work, I'm focusing on trying to make it just a little bit less daunting to enter electronics, or to skill up in electronics too. So doing some, through-hole soldering kits, some intro surface mount soldering kits, and some like little hackable badges, as well as just like handy tools or whatever kind of catches our eye and we start thinking about.
You've actually got some things to show us as well, so let's get them up on screen. There we go.
So this is like a smattering of our kits, and these all come as parts. Pretty much most of them come as parts, and so you solder it yourself. And so our little clouds are our first kind of introductory level, like learn how to through-hole solder kits. And
would you mind holding them up and just showing them off front and back and things?
Yeah. And so it's super. They're really simple. There are 3 LEDs on the front, and there is a lithium, CR2032 battery on the back, and a switch. And the LEDs are like the self-blinking style. No. I know that's the only problem with this holder, is that they're hard to get out without.
I was going to say it looks awesome.
But we'll see if any of these are actually alive. There we go.
Cool.
So it's just like very like quick, instant gratification, kind of approachable stuff. And then this guy is, if you have a happy storm cloud, you have to have an angry rain cloud. Or you have to, if you have a happy rain cloud, you have to have an angry storm cloud to kind of like balance it out. You have to have the yin and the yang. So we also are doing stuff. So it's like it's voting season in the U.S. right now. We got November 8th is like the big midterm election day, and so I did these because I kind of wanted something that was like one of the I voted stickers to show off your voting pride.
Nice. And are these LEDs are under control of a little circuit on the back, or are they the same kind of? So nice.
So these guys are it's a transistor oscillator is what's happening, and so all of the red LEDs are hooked up to one transistor, and all of the blue LEDs are hooked up to the other one, and the resistors and the capacitor right in front of it there make up this little oscillator circuit. So it's a stable blinking where one goes and then the other goes, and it kind of changes rate as the battery goes down, as your voltage changes. But I also I know that some people don't like the blinky, so I also made there be a solid solid option for these guys, and that just it just basically bypasses the blinky part of the circuit and pulls them all solid high. And then we have the same one in like a more instant gratification version that's all surface mount stuff.
I was going to say, so those first two were through hole entirely, are they?
Yeah. So these two are entirely through hole.
Okay.
It's a little bit dense. We have full instructions online, like step by step, of how we like to put them together.
I was going to say some of the ordering might be important, that kind of thing. And
it is a little bit important on this one. We like to do the LEDs last because there are a lot of through hole legs that come out pretty close to them. So we like to do those, to have that be the very last thing that you do. But we have all the step-by-steps, and then let's see. Then we have this one's the Halloween themed one coming out. It's the spooky coffin. It just does like a little like reddish glow.
Is that flickering a bit? I can't quite see through the camera. But
it's the flickering LEDs are a little bit hard to see, but
we can get the impression, I think, just about. Awesome. Okay.
So
are these badges? Do they sort of pin onto your clothing, or what's the idea there?
Yeah, we do give you like a pin with a sticky back. And
right
now, because it's interesting. You would think like, oh, this is a big badge. Surely you could find room for a pin on here, like a dedicated place for a pin. But it's actually a little bit tricky, and because you have to keep space in front of that battery holder to slide the battery in and out.
Yeah.
With that style. So yeah, we find the best thing to do is to just put the pin on top of to stick it on top of the battery. That way you can still get the battery in and out underneath the pin, and then you can still wear it. But we ship them with a stick-on battery holder or a magnet in case you aren't interested in wearing it, but you want to like magnet it to your
fridge. Yeah, nice. Yeah. Okay.
Yeah.
Neat.
And so then we also have like some surface mount ones, and these are our three surface mount badges right now. This is the one that we just came out with. It's called the SMT Garden, and
it's a lot more complex on the back. Oh yes, brilliant.
So
now it's got color in it. I recognize it. Sorry.
Yeah.
It's funny what pattern recognition does in your brain, isn't it?
Right? Like, oh yes, now I've seen that. Right. It's LEDs. They just make everything better. So yeah, this one is designed to be a practice, like a practice board, get you a lot of experience with surface mount soldering. Okay. So let's see if I can peel the batteries off right now. So we have all of these rows where you can practice soldering surface mount components of various sizes. And, you know, I wanted it to be like in a row so that you could practice like getting them straight, and even if you wanted to or not, whatever, it's cool. That's what practice is for. You're not going to be perfect off the start. And so we wanted all of this big practice area. We have like diodes as well as capacitors and resistors, 1206 down to 0402 if you really, really, really want those.
Neat. Okay.
And then the actual active circuit is all up here, and it's all made with 805 components, as well as the LEDs and some resistors on the front. Yeah.
Neat. So those practice lines are just purely for practice, isn't it? If you get it wrong, there's no harm.
Yeah, exactly. So yeah, so you can you don't have the fear of, you know, messing up the circuit or whatever when you're doing those. Yeah. And then I did a few things because I think it's helpful to show somebody in a practice kit things that they will likely encounter in life. And one of the biggest things when people go to surface mount solder is that they encounter a component that's attached to a ground plane. And all of a sudden they're like, wait, I was getting good at soldering and now I can't solder anymore, you know? And that could be really frustrating. And so we have like half of the components here have one pad with a ground plane, soldered to a ground plane, so that you can just practice that and get that feel and be like, oh yeah, there's more heat sinking. Maybe I need to bump up my iron temperature a little bit. Maybe I need to hold the iron a little bit longer on this pad. Yeah. Very nice. Yeah. So that's like the big one. And then we have
just before we move on from the garden, is that programmable in any way, or is that again it is what it is?
No, it is what it is. So
I just thought I saw a USB connector on there. I was wondering.
It is just for power.
Okay, fair enough.
It's just for power, just in case you want to, you know, have it hooked up without batteries.
Neat. Okay.
Because that was one thing when we went to we had like a booth at a couple of shows this year for the first time. And I was like, oh my God, I need to power all of these boards because, you know, these are tiny. So we needed to make displays that showed a bunch of them all at once. And it just seemed really wasteful to be battery powering them all. So I actually made this little board, which is the coin cell power board. Very cool. The way it works is that it just slides into, let's find one that doesn't have one. I put batteries in them all without getting this one out. So it just slides in to where the battery is, and then hooks up to USB. And let me make sure that I just have this one on the right setting. Yep. Yep. Okay. And it hooks up to USB. True. And then there's an on switch, and then there's an on switch on the board as well. There we go. And so this one's a little more subtle. So yeah, it just does like a little heartbeat blinking pattern. But yeah, it was a good way to power all of our badges and not have to be swapping batteries out all the time. And I'm actually working on, we're just about to actually have this one for sale because there seems to be a lot of interest in people who also have the same problem. A lot of badges, you want to make kind of a semi-permanent display of them. Yep. And yeah.
Cool.
And then this one, you can also, like some of our kits, like this one, the Foxy Pride, we use some funky colors of LEDs on this one that have pretty high forward voltages, like around 3 volts. So while they will kind of work off of a single coin cell, they're much
Probably
better.
Dim pretty quickly, won't they?
Yeah, they dim quickly, and it's much better to use 2 2016s in series to at least get you like a 6-volt overhead.
Okay.
Yeah, so we have the option for this board to choose either 3 volts or 5 volts because it's USB, and that way you can power like a variety of things from it.
Okay. Yeah.
Yeah.
Nice. Is that board thicker than the normal 1.6 mil, just so it sits in place for battery?
Yes, it is 3.2 millimeters.
Oh wow, okay.
Yeah, so it
chunky.
basically emulates a coin cell.
Yeah.
And so yeah. And there are also like a bunch of test points on it. You can definitely use it as like a way to test out some things that are coin cell powered. And if you want to like make sure that your USB is actually giving you 5 volts, we have like test points for 5 volts, test points like, after the switch and into the regulator and stuff like that. So
nice. Cool.
But yeah, so, I've been making these in the past couple of years during the chip shortage. And so you asked about like, oh, well, are they programmable? And the answer is no, because it was really hard to find processors.
And that's a completely legitimate thing to say. It's been painful, hasn't it?
Yeah, it's been hard. Also, it is cool to show fun uses for analog electronics, and it's still on my to-do list. I'm lagging a little bit on this, but all 3 of the surface mount ones are 555 timer based.
Okay.
And so this one is called P.S. I Hate You because I made it around Valentine's Day. And and the whole idea was to make a super annoying board layout so that people who really were OCD and wanted their components to be square and straight, like there's not a 90-45 degree thing on it.
Actually, I have to admit, I was looking at it from the front side. You had your not a battery sticking in, and it was at an angle, and I was going, what's going on there? Is it just
right? Because not even the battery is at an angle, it's square.
Brilliant.
So so that was my little snarky Valentine. And yeah, so but they're all 555 timer based, and they all do like slightly different blinking patterns and pulse trains from 555 timers. So something that I want to do is I've talked about them a bit on live streams. I have like some videos that are out there about them, but I would like to write up some actual tutorials that talk about it and show the pulse train at different points on the circuit and what they're actually doing.
How to tune your badge to be unique.
Yeah, you totally could. You could change out the resistors and capacitors and hack your badge to do different blinking patterns.
Neat.
You can hack your badge. You just have to do it in the old analog way by changing out the components. Yeah.
Cool. So there are 2 things on your mat that we've not seen yet, which is I want to call it a face with a big beard, but I'm not sure.
It's the Krampus.
Okay.
It's the Krampus. So yeah, it's hard for me to like get on board with sort of like traditional holidays, as evidenced by the snarky Valentine, right? So our Christmas/holiday thing is a Krampus, who is and it kind of has this sort of like alpenglow tie-in too, because it is a mythical character that is celebrated in like alpine towns in Austria and Germany a little bit. And the Krampus is, Santa rewards the good children, Krampus punishes the naughty ones. Yeah. So it's kind of a fun, little irreverent figure that way. And Krampus looks pretty awesome. He has this like he's kind of this demonic creature a bit, and he has like this long tongue and horns and this great beard and stuff. So he's just very, very visually interesting, which is nice.
Yeah.
And then this one actually is programmable.
Okay.
So
and it comes through the board as well. Look at that.
Yeah.
Lovely.
Yeah, we were experimenting with some like backlight sort of diffusion kind of stuff. And, you know, yeah, I mean, I knew the tongue was going to kind of come out as point sources, but, you know, that was okay with me. I really like how the eyes are,
they look
pretty
good.
Continuous.
Yeah.
So the idea with this one, and this one was like kind of designed just pre mega chip shortage, I would say.
Okay.
So I decided to try to use, well, I looked for the cheapest, smallest Atmel processor, 8-bit processor that I could find, which it turns out is the At-Tiny 4.
Okay.
And it has 512 bytes of flash and 32 bytes of RAM.
Oh, no.
Yeah. Yeah. And so, I mean, a lot of people program it in assembly. I didn't program it in assembly, but it's actually like a really great, it's a great way to challenge yourself to learn how to read the datasheet of a processor and learn how to just directly access ports and do bit shifting and to set up timers to do kind of patterns that you want and things like that.
Yeah.
And so I have to
look it up after we've been talking.
Yeah. So the processor is actually this SOT236 one. And yes, so you could actually reprogram it. We did we did sort of cheap out and do surface mount pads, and so we sell a Pogo kit that that allows you to program it. That we include a USB ASP programmer with it and a Pogo adapter kit that you can use to reprogram it.
But it comes ready to go, presumably.
But yeah, it comes.
You don't need that. Yeah.
Yeah, totally.
Awesome.
Totally comes all ready to go. And it was really fun. Like, this uses all available space to do this, because so we have the one that's like, it's sort of like a pseudo random sort of flashy thing, right? And then there's the other mode, which is the slow glow mode. So it blinks out and then comes on.
Yeah. And
yeah, that uses all 512 bytes.
Poof, gone.
Yeah, it was like it was interesting. Or actually, yeah, I think this one does. Oh, it might be the RBG that uses all 512. Oh, I think it's RBG who uses all 512. So this was a board that I made. Oh, this is interesting. This is one of our older. This was one of the first prototypes. You can see the bodges.
Yeah.
Check it out. Look at my nice enameled wire work under there. There are also traces that are lifted too, I think. Oh, I could show it under the microscope. Hang on. Gotta show the bodges. Okay. Switch this. Yeah.
There you go.
All right. So you can see actually the trace that's in the middle of them. That I very carefully cut and lifted right there. There's a pretty easy way of doing it with a X-Acto knife, where you just like very gently cut that trace. And I do this under a microscope. So you gently cut that trace, and then you just like pry up the edge a little bit, and then you grab it with a pair of tweezers and you just like peel it right off. Yeah. And if you pre-cut the end, it just like zips right off, and it's a very satisfying feeling. But so this one was the first At-Tiny 4 project. I don't even know if this one works. We're going to find out. Yes. Also, I am not great at labeling on-off switches.
Never mind.
Yeah. Oh, darn, I don't have the other one here. But let me see if it's just the battery. This one just might also not be in a working state. Yes, I think that this one. Oh, hey, there we go. Okay, so I can do that there. So this was the first one, which was very, very scary because she has dead zombie eyes. But let me see. So that was the red, the glaring red. This one. Oh, hang on. Am I doing that? Yeah, it's not Sorry, live
No,
demo.
don't worry. Never mind.
But my other one, it goes through a rainbow because there are RGB LEDs, and so it goes through this rainbow fading sequence, which was very interesting because I only had 2 timers to create that sequence with, and I had 3 LED colors. So I had to do some nifty shenanigans in order to get that to work out with an @tiny4, and then an extra thing for like the mode switch, and yeah. But yeah, I'm working on a version of this that's made into a dev board that so that other people can also work with this processor a little bit easier. I added like this switch for programming, which isolates the lines for programming and then reattaches them. And you can solder a header on and just plug it into a solderless breadboard and make your own circuit if you want. And you can isolate that from the LEDs that are on the board, things like that. So I would like to encourage more people to actually like learn how to directly control. I guess it's now called bare metal programming. That's the buzzword. So bare metal programming on 8-bit processors is pretty fun.
Yeah, cool.
Yeah.
Very nice. And your kit's available for sale on Tindy and possibly elsewhere?
On Tindy and on our website, alpenglow-industries.com. So, and we're Alpenglow Industries on Tindy as well. So either spot.
I think we have links to both in the description. So yeah, if you're interested, please feel free to go through.
Yeah.
But brilliant. No, that's fantastic. Thank you for showing off all your toys.
Yeah, no problem. Happy to.
I think we're pretty much at the end of the hour. Are you happy to move on, or is there anything you'd like to talk about? Last thing to shout about, anything like that?
Oh man. I don't know. I like the last thing I would say, I encourage everybody to like share their knowledge in a friendly and open way, because that's how we all learn.
Yeah.
So yeah.
Great.
Yeah.
Well, thank you very much.
No problem.
We spent a lot more time talking about yarn than I expected, but it was brilliant. Yeah.
Yarn, electronics, it's all there.
Great. Fantastic. Well, thank you very much for spending the time with us. It's been great to talk.
Yeah, no problem. It's been good to talk to you too, Eddie. Thanks so much for having me on. It's been so
thank
fun.
you. Yeah, it's been great. Next week we'll be talking with Rachel Mant, aka Dragon Mux. But for today, that's goodbye from us.
Nice. Bye, everybody.
Bye, everybody.
Thanks for joining.